Rust, a systems programming language named after a fungus that somehow made fighting the compiler a good thing. Created by Graydon Hoare in 2006 as a side project and later developed with support from Mozilla, Rust was built to solve one of programming's oldest problems: writing software that's both fast and safe while still delivering C++ level performance without a garbage collector. To get started, just copy and run this command if you are on Mac or Linux. For Windows users, download the installer and follow the instructions on screen. If you get this message, you are good to go. Then, using cargo new and your project name, you can create your very first Rust project. This command will generate all of these files, and inside the source folder you will find main.rs, and inside it a function called main, which is the entry point of our program. Cargo has automatically generated this hello world program for us. Here we are using the println macro to print hello world to the terminal. Now, to declare a variable, we use the let keyword followed by the variable name and its value. To print the value of a variable, we can use curly braces inside the double quotes, and then after the double quotes add a comma followed by the variable name. Unlike most programming languages where you can change a variable's value at any time, variables in Rust are immutable by default. This means that once a value is assigned to a variable, it cannot be changed. For example, if I try to assign a new value to this variable and run the program, Rust gives me an error saying cannot assign twice to immutable variable. And the fix is right here in the error message. We simply add the mute keyword to make the variable mutable. Now, if we run the program again, it works without any errors. Declaring a constant is very similar. We just use the const keyword instead of let. The main difference is that constants can never be mutable, so you can't use the mute keyword with them. When using let, we usually don't have to specify the data type because Rust can automatically figure it out from the value we assign. However, this doesn't work with constants. When declaring a constant, we must always specify its data type. Speaking of data types, Rust has two main categories of data types. The first one is scalar types, which represent a single value. By the way, we use double forward slashes to add comments in Rust. In scalar types, we have four main kinds of values. The first one is integers, which represent whole numbers without any decimal points. To specify a data type, we add a colon after the variable name followed by the type and then the value. Here, i32 means a signed 32-bit integer. In fact, i32 is Rust's default integer type. There are other integer types as well, such as i8, i16, i64 and more, depending on the range of values you need. Rust also has unsigned integers, which start with a u. The second scalar type is floating point numbers, which store fractional values. You can use either F32 or F64 to store a fractional number, and if you don't specify a type, Rust will default to F64 whenever you assign a fractional value to a variable. Next, we have booleans, which can store either true or false. To declare a boolean value, we use the bool type. After this comes characters, which represent a single character. For characters, we use the char type. Also, characters must be written using single quotes. If you use double quotes instead, the compiler will throw an error. And after scalar types, we have compound types, which group multiple values into a single value, such as tuple. A tuple can store multiple values of different data types in a single variable. To create a tuple, we specify the types inside parentheses after the colon and then assign values in the same order. To access the values from a tuple, we can destructure it into multiple variables. Now, x, y, and z contain the values from the tuple. This process is called destructuring because we are breaking a single tuple into multiple parts. Here, if I print these values, it will be same as the values from the tuple. Now, if you only want a single value from the tuple, you can access it using a dot followed by its index. Next, we have arrays. Like tuples, arrays can store multiple values. However, while tuples can store values of different types, arrays can only store values of the same type. To declare an array, we use square brackets. We can also clearly specify the type and size of the array. Here, i32 is the type of each element and 5 is the number of elements in the array. There is also a shorthand syntax for creating an array where every element has the same value. This creates an array with 5 elements and each element will contain the value 3. To access array elements, we can either destructure the array just like tuples or access individual elements using square brackets and the element's index. Now let's look at conditional expressions. Writing an if expression is pretty straightforward. First, we use the if keyword followed by a condition. Then, inside a curly braces, we write the code that should run when the condition is true. If I run this program, we can see number is less than 5 printed to the terminal because the condition is true. We can also use an else statement to run a block of code when condition is false. To check multiple conditions, we can use else if. However, using multiple else if statements can sometimes become repetitive. In situations like this, we can use match. To write a match expression, we use the match keyword followed by the value we want to compare. Then, inside curly braces, we write the possible values to match against, followed by fat arrow and then the code that should run when a match is found. And instead of an else block, we use underscore, which acts as a catch-all case. The code in this branch will run if none of the previous values match. Now let's look at loops. Rust has three kinds of loops, with the first one being literally called loop. If I use the loop keyword and inside the curly braces increase the value of number by 1 and then print it, you will see that this code keeps running forever. That's why the value of number keeps increasing in the terminal. To stop it manually, you can press Ctrl C in the terminal. Or inside your code, you can use the break statement. Now, when we run the program, the loop automatically stops once number reaches 10. The next type is the while loop, which runs as long as a condition is true. To write a while loop, we use the while keyword followed by a condition and then the code inside curly braces. This loop also prints number from 1 to 10 and then stops. That's because once the value of number reaches 10, the condition number less than becomes false and Rust exits the loop. We can also use a while loop to iterate through the elements of an collection. Here, I've got an array and an index variable. The while loop uses that index to access each element and print it. But you might already spot a problem. We have to keep track of the array's length ourselves, and if we accidentally access an index outside the bounds of the array, Rust will give us an index out of bounds error. Fortunately, there's an easier way to loop through collections, the for loop. We use the for keyword followed by a temporary variable, then the in keyword, and finally the collection we want to loop through. Here I am using element as the temporary variable and printing each value. This approach is simpler, safer, and usually the preferred way to iterate through arrays and other collections in Rust. After that, we have functions. You have already seen the most important function, the main function, but you can also create your own functions using the fn keyword. First, write fn, then the function name followed by parentheses, and finally the code inside curly braces. To call a function, simply write its name followed by parentheses. If I run this program, it prints my function to the terminal. We can also pass values to a function through these parentheses. To declare parameters, we write the variable name followed by a colon and its data type. Here, I've got two parameters a and b, and I'm simply adding them together, storing the result in a variable called sum and then printing it. Now, if I pass two values to this function, their sum will be printed. A function can also return a value. For example, instead of printing the sum, we can return it. To do that, we use arrow symbol after the parentheses and specify the return type. Since we are returning an integer, we will use i32. This works perfectly fine, but we can make it even shorter. Instead of writing return sum, we can just write sum. This works because sum is an expression. In fact, we don't even need the sum variable. Since a plus b is already an expression, we can simply write a plus b and Rust will return the result automatically. Okay, now let's look at Rust's most unique feature, ownership. But before we do that, we need to talk about strings. So far, we have been using text inside double quotes. These are called string literals. They are built directly into the program and are great when you just need some fixed text. But what if you want to create text while the program is running, add more text to it or modify it later? For that, Rust library provides the string type. To create a string, we call the from function from the string type and pass our value to it. Unlike a string literal, a string can be modified. Because a string can grow and change while the program is running, Rust needs to keep track of who owns it and when it should be cleaned up. That's where ownership comes in. It follows three simple rules. These rules apply to all values in Rust. For example, here, at first glance, it looks like we are copying S1 into S2. But Rust actually moves ownership from S1 to S2. That means S1 is no longer valid and trying to use it will give us compiler error. But what if we want a function to use a value without taking ownership of it? That's where reference comes in. By adding an ampersand, we can borrow a value instead of becoming its owner. Now, the function can use the value, but ownership stays with S1. Because ownership never changed, we can still use S1 after the function call. And if we want the function to modify the value, we can use a mutable reference. This allows the function to change the value while still keeping ownership with the original variable. Finally, if you want extra functionality in your project, you can add libraries using cargo. After adding it to our project, we can import its features using the use keyword. You may notice these double colons. In Rust, double colons is used to access items inside modules, types, or libraries. And now we can generate a random number like this. And at last, to run our program, we use cargo run, which automatically builds and runs the project for us. Or if you want to use the Rust compiler directly, you can use Rust C followed by your file name. This compiles the program and creates an executable. You can then run that executable directly.